Welcome. This video is to look at the pattern of linear change for a quadratic and how you write that equation. So we can see that we have a quadratic relationship. F of x is x squared. Here's some x values. So if it's squared, negative 2 squared is 4, negative 1 squared is 1, 0, 1, 4, 9. Now, we can look at the change, the first difference, and we notice it goes down 3. And from 1 to 0, it goes down 1. And from 0 to 1, it goes up 1. 1 to 4, it goes up 3. And 4 to 9, it goes up 5. Now, when we look at this pattern, negative 3, negative 1, 1, 3, 5, we should recognize that that is a linear pattern because the second difference, or the difference here in all these, is plus 2. Okay, so that second difference is why it's quadratic, and notice that this pattern has a constant change, and that's why this is a linear, because this is a constant when you look at the change. So what we need to do is we need to figure out what's the equation for these data points, negative 3 and negative 1, 1, 3, and 5. We know it's a linear equation. So we're going to use what we have here as our x values. I'm going to start with 0, because when x is 0, that'll give us the y-intercept. And then I've got 1, 2, 3. I'm going to go with these. So again, I'm looking at the linear change. To go from negative 1 to 0, we can see that the linear change is negative 1. To go from 0 to 1, we can see that the linear change is plus 1. And when we go from 1 to 4, we can see that the change is plus 3. And when we go from 4 to 9, we can see that the linear change is plus 5. So to write a linear equation for this pattern of change, this linear pattern of change, negative 1, 1, 3, 5, first we need to find what is the slope. And the change is plus 2. So we know that our slope is going to be plus 2. Now we also need to figure out what's the y-intercept for y equals mx plus b. And we notice that when x is 0, the function returns a negative 1. So going back, we can see that b equals negative 1. So therefore, our equation for the linear change is 2x minus 1.